To create a plot boundary in the UASHub, you will first start by hovering over the Manage Data tab, then clicking Create Plot Boundary. You will need to search for your project and all uploaded mosaics will appear. To pick a mosaic to view, click the square to the left of the date. It is helpful to choose a mosaic in which you can clearly see the plant growth. This will make it much easier to create your boundaries. It's also helpful to have a copy of your plot layout nearby for reference. To start creating the boundary shapes, click the Create tab. We will be creating our row number 1. On the mosaic, click the upper left corner of the plot. This will move your blue pinpoint to this spot. This inputs the pinpoint's coordinates into the latitude and longitude boxes. Input your plot's width and height in meters. You can adjust the angle now or later. Make sure to have the correct ESPG for your plot's location. Input the amount of plots in the range. Click Set, then click Generate. The plots will appear. To edit this row, it is very important to remember to click the Edit tab above. These plots are good, but we do not want to include the alleys. To account for the alleys, we are going to input an offset. We are inputting the alley width in meters and clicking Apply All and switching to column 1 to a 0 offset, since we do not need to account for an alley before it. Click Update to see changes. Now we will account for a vertical offset. To move all plots up, you can input the meter length you'd like to move. This can be a negative or positive number to move up or down. You are able to change individual plots' offsets, demonstrated here. Check all plots to make sure it aligns with desired plant area. After any changes, click the Update button. You can also click on a plot to see row and column identification. Earlier, I mentioned shifting the plot angle. The plot angle is a value that may be positive or negative depending on placement. The angle is something you may have to try multiple values with until an angle appears that matches the layout. Like all other values, the best fit may be a small decimal number. Once decided on a plot angle, use the same for all plots. If needed, you can shift the plots, but do not change values such as angle, plot width, or plot height. Now we will create row number 2. Click the Create tab above. On the mosaic, click the upper left corner of the second row and input the plot's values again. These should be the same numbers as before. Click Generate and click Edit. Scroll through the row options and select the number 2. Again, go through the process of making individual edits as needed. A helpful tip is to pay attention to what tab you are on, either the Create or Edit tab. It is an easy mistake to stay on the Create tab when you are trying to make edits. This can result in multiple unwanted rows. You can always delete rows in the Edit tab. You should make sure the rows are also created in order. You can change the number of your row in the Create tab if needed. Repeat the creating and editing process as many times as needed. Skip the time mark 15:18 to learn more about the export process. To export the plot boundary, click the Export tab. Choose a plot and GeoJSON file format. It's recommended to save both. Save to the preferred location. We will now combine an identifier sheet and CSV file format with the plot boundary. An identifier sheet is an Excel file with each plot listed row by row with range and column numbers. It is important to include a field ID or FID number with each individual plot. This is a unique number associated with a plot. You can think of it as a plot serial number. This is what we are creating on the right side of the screen. Make sure to save as a CSV file with the FID. We will now open QGIS. Import the plot boundary GeoJSON file and the identifier sheet into QGIS. Right-click on the identifier sheet and click Open Attribute Table. It will show you all the sheet's information and the FIDs you've created. If you click on the column headers, you can sort by that attribute. Now, open the Plots Boundaries attribute table. We need to add an FID column, so when we combine the identifier and boundary, it will be seamless. Click the pencil button above to toggle editing mode. Click the Open Field Calculator button above. In the output box, write FID and search for ID and click on $ID +1. This will make ID appear on the left starting from 1. Click OK and the FID will appear on the attribute table. Be sure that the plots on the identifier sheet and the boundary file have the exact same FID so that no overlapping or misplacement occurs. Right-click on the boundary file and click Properties. On the left, click Joins. Click the green plus button on the bottom. The join layer will be the identifier sheet, and the join field is the FID values from the Excel, and the target field will be the FID from the boundary file. Click the editable join layer, then click Delete Cascade. And the custom field name prefix, delete the text. Click OK twice. Now open your attribute table in the plot boundary. The FID should be updated correctly. You can now export the updated boundary as a shapefile with the correct ESPG for your field. Save to the desired location. Always make sure the CRS and ESPG is correct. Save.